Why do you threaten us with this?
Because I love you.
Class.
Remember,
Are you saying you hate Mr. Hall?
No, don't.
That's
put
what you're
words
saying?
In my
You just said
mouth.
you hate Mr. Hall and everything he stands
David, did
for?
you say you're bald? I'm so
Oh,
sorry.
oh, wow, you going there? You going there? Okay.
all right.
I see how it is.
Today, what we're going to talk about is the metallic bonds. This is the last and final bond that we're going to hit. I'm going to stress something to you. You see some similarities with your covalence and your ionics. You're like, oh, they're sharing electrons, forming bonds, interactions, positive, negative. And you see all this, yes?
With my own two eyes.
They're very good. Okay? I don't want you seeing with my eyes. Especially because they're not that great. I need a new prescription.
I don't need glasses, Mr. Hall.
Congratulations. You know what? Mr. 2020.
I got that.
It's great to be you. Somebody report him to Miss Endicott. I'm being bullied.
You have 4 eyes. Sorry. Don't, Mr. Hall, if I have
Wow.
glasses, okay? I
I
just
come in this morning just to teach this class. One kid looks at me and says, my class is easy. And that it's a dream and a cakewalk. And another kid looks at me and calls me 4 eyes.
And then
He
one
like
didn't even-
Man!
He like calls me 2 eyes like it's an insult.
It is.
You're
I have more
you're
eyes.
the anomaly.
One kid didn't even show up due to boy issues.
That's not. Did you think God created
Metallic
Adam
bonds.
glasses? No, he didn't.
Metallic bonds.
I wasn't there.
Metallic bonds are really not actual like full-on bonds, but we're gonna go with it. So these are bonds found in metals.
Whoa.
Revolutionary.
And they're very special. Whenever you look at this, they have very special properties. And this is why I like to talk about metallic bonds, because it brings real world into the class and you enjoy it. So you remember how I told you about the D block? How they're the freaky weird kids? And like none of us like ever want to like worry about them or anything, all that stuff.
Is sodium a metal?
What is it?
Is sodium a metal? Is it just everything?
Yeah, it's
left
metal.
it? Oh. Well, that's weird.
Except the weirdest part is what happens
Oh.
whenever you get some pure sodium. You can cut it. It's really cool. I didn't have enough money to buy in here, I would have.
Ah,
Very dangerous.
Do you okay, Tim?
no.
I didn't even know you had glasses.
Yeah, I know where he decides to wear them. Okay, so metallic bonds are from metals.
That's why I don't wear them.
But here's the thing. They don't change in many aspects. They still hold the one true aspect. They
They
want
want love, Mr. Hall.
a full
Full
octet.
octet.
You were close.
I was close. But isn't love
That's
just
pretty much that's
one big full
that's
octet?
like love in the element language.
Eli, I want a
I
full
can do
octet
it.
with you.
Whoa.
I'm not addressing that. I'm gonna let Mary address that. I'm not even here today. I told her kids that come up to me and say that I thought you weren't gonna be here today. I said I'm not here. I just live rent free in your head and torture you so much that you're imagining
This
me.
is a schizophrenic
astral
psychotic
projection.
delusion. Get
Hey,
that.
Dale, thanks for these apples, man. They tasted like poison somehow.
Yeah, they probably will.
Can I?
Why just-
I was gonna say, can I get one?
Because Sorry, bro.
You know,
You want some raisins?
Oh,
or
that's because I
something?
I bet they taste like poison.
You want them?
I ordered
All right.
poison apples from McDonald's.
Here's what's gonna happen, okay? They want a full octet. Metals are smart.
Do bonds have soulmates?
What?
Do bonds have soulmates?
Aw, it's so romantic.
No.
Well, jeez.
Aren't
Isn't it February
I don't
1st?
like the favorite.
Yeah.
Oh my
Yeah.
goodness, I forgot to say it. Happy Happy February 1st, guys.
Aren't metals the ones that are just like, yeah, I'm getting rid of all my electrons. I don't want those anymore.
So here is a sheet of metal. So this sheet of metal, I'm gonna go with something that everybody in the room is very familiar with. Sheet of aluminum. So we got some aluminum atoms in here.
Oh, goodness. I think I just
Don't you mean aluminium, Mr. Hall?
Don't ever, I
No.
will.
I'm from Southern
Jail.
West Virginia, it's aluminum. Alright?
In the world, it should be.
So when you break this thing down, you look at it, here's aluminum. I have a question for you. How many, when we look at aluminum, how many protons?
It's fighting.
How many protons does aluminum have?
13.
13.
It's number 13.
How many electrons does aluminum have?
Should be 13.
13, right? Okay. So if I ask you something like, I don't know, let's say the orbital notation for aluminum. We work that out. Make
You're
sure.
so fast.
How do I?
He probably has it memorized, Tanner.
It's crazy.
Well, let's just go with this.
You should
that,
teach chemistry or something, Mr. Hall.
Yeah. I will say this. Whenever I went and I observed Wyoming geese, they were doing this. And as I watched them do it, my skin was crawling.
They're just bad at it.
Well, they would do the electron configuration part, and then above it, they would draw out orbitals, the dashes for the orbitals, and fill them in. But they wouldn't line them up. And I'm just sitting there, I'm like, that ain't right.
What does that mean? What have they done?
It was pretty jacked up. I don't want to show you because I never want to show you how to mess something up that bad. So, I did this for you so you could easily tell Mr. Hall something. Okay? Hey, how you doing? Oh, good. Welcome back. Oh, I'm happy for you to be here. Nothing back? What did they say?
Oh, God, they smell horrible.
Wow, you know what? Kid comes in, looks at me, tells me my class is easy. Guy was mean to me, bullies me, calls me 4 eyes. She comes in and all I can get is hey. But nothing else. I bet you if Hannah was here, I'd get more than a hey.
Oh,
You know, Hannah's never said a word to me, Mr. Hall.
That's because she don't like you.
What a rude child.
Yeah, face your daughter.
Raising her right. How many valence electrons does aluminum have?
yeah, these smell horrible, Mr.
Is
Hall.
that, would it be 1 because 3P is the outer?
Would it be 3, Mr. Hall, by any
Don't
chance?
make that noise at me. That
Wait,
makes-
what was the
Is
question?
it-
Oh man, I tell you.
wait,
Repeat
wait.
the question.
I think we messed up, guys.
Your valence
3.
electron. Oh,
3.
no, I was
Yeah.
3. There's
Yeah.
3.
That's 3. That's 3, okay?
I'm disgusted that you guys can't.
I did it this way so you could actually see the 3.
Word.
But you also could look at the periodic table and look to see aluminum's in the 13th column and know that
Oh, yeah.
aluminum has how many valence electrons? 3. Okay? 13th column has 3. Here's the thing.
That's not a D block.
Here's aluminum. Aluminum's just chilling and hanging out. Okay? And everyone's looking and saying, I want the full octet. Aluminum's like, I want the full octet. If I only had a full octet, I would be stable. And watches, everybody's struggling, trying to wheel and deal electrons, and it's like, why is this going on? Like, what is happening? What is this? So aluminum looks at all the metals, the transition metals, okay? Not the alkali metals or alkali earth metals. Alkali metals are column 1, alkali earth metals are column 2. They all look and they go, okay, I want the full octet. I want 8. If I go to the second energy level, if I go to the lower energy level, I have a full octet. But as I sit right now, I have 3 in the 3rd energy level. They're my problem. So here's what's happening. Aluminum comes up, gathers these 3 electrons up, and has a conversation. Says, yo, you've been living here rent-free forever. I've seen you through high school. You've been living in the basement playing video games, and you ain't got the job. I'm sick and tired of it. You're a 35-year-old. It's time for you to grow up, electrons. I'm done.
Why are you looking at me?
I thought you were going to insult me.
You're 35 years old and you haven't got a job yet, damn.
God damn.
That's all my manager thought I was. When I started working at McDonald's.
35.
Oh,
Yeah,
man.
he said, you're a 35-year-old man and don't know how to wash dishes. And I was like, I've never used this thing before. I'm sorry. And he's like, well, a 35-year-old. I was like, I'm not 35. And he's like, what? 'Cause I guess we hired somebody that was like 35 the same day I showed up. And so he just thought I was that dude. He doesn't do the hiring. He just kind of like,
Dale, you're not 40.
All right, anyway. Here's what aluminum looks and says. If I take these electrons and move them somewhere else, I'll have a full octet. So
Yeah.
guess what the aluminum does?
They move them somewhere else.
Aluminum kicks those bad boys out. Yeet.
How does
Goodbye,
it
Dale.
do that? Aluminum's
They gone. Now how many valence electrons does aluminum have?
2,
10.
or wait.
That's the first energy level. This is
Oh,
the
yeah,
second.
no,
This is the second.
8.
Place it in here, though.
8
Woo!
has a full octet.
Congratulations, Illuminati.
Now, here's the cool part. What happens here? We lost 3 electrons, right? How many electrons we got now?
Like 10,
So 10. It's 10 negative charges. How many positive charges?
like 13.
13. That's a plus 3.
Oh man.
Every one of these forms a 3 plus charge. And now they've yeeted out these electrons. Hey, somebody remind me again, what are electrons?
Negatively charged subatomic particles.
Very good, negatively charged subatomic particles. So they're negatively charged and we yeet these things out. Hey, they're negative. These are cations, they're positives. What do opposites do?
They attract.
They attract. So guess what happens?
They
It
attract.
attracts.
Holding on.
Here's all these electrons
Are they attracting?
They're repelling.
that are attracted
Help you out.
Oh, I think it's
to the positive cations.
Wait, the electrons they just kicked out? Okay.
Hang around.
Oh, never mind.
What
I
else would
remember
it look like?
talking about this. Never mind.
Whoa.
Exactly. Right? So they're hanging around.
I don't appreciate the electron prejudice.
Now here's the cool thing.
Can I appreciate you?
Okay.
This
whatever.
right here is what gives metals all their properties. This is the main masterful idea. The electrons left behind the electrons that are lost stay around due to charges attracting. This gives metals all their special properties. All the properties are there in metals because of this, and it has a very special name. What this is called the sea of electrons.
awesome.
Why did you write 13 minus 3 equals negative 10 plus 3? What does that mean on the electron thing on the left side?
Okay, 13 minus 3, I lost 3 electrons.
Mhm.
Okay, I have 10 electrons left. I still have 13 protons. 13 minus 10 is 3.
Never mind.
That gives me a charge.
Yeah, I thought I didn't know if you were checking there. Never mind.
This is what gives every special ability and property to metals that we have. And you need to be thankful that we have them. If we didn't, you wouldn't be able to live the life that you live. We would not be able to do the things that we are doing. So, we're going to go through this. This gives special properties to metals. So I want to talk about the properties. They are very, very special. What?
Properties of metals or metallic bonds?
Properties of metals. This comes about because of the metallic bonds.
Is you said that was only the transition metals, right? The aluminum, like the thing that
Yeah.
come out. Okay.
And I know that aluminum's not a transition metal, but it still doesn't.
What signals, for lack of a better word, an atom to dispense of its unnecessary electrons?
It was the dude that was sitting there and watching everybody do it the hard way and thought, I'm just gonna do it the easy way. The truth is, they just do it.
Is there like a scientific fact reasoning, or do you
That's
just?
just- we just know they just do it.
Okay.
That's why they have all the special properties, like we're gonna talk about. So like the first property we're gonna talk about is metals. The very first one has a very special name. You know this property, but you are not so much, may not be so much familiar with this word. The actual property is called luster,
Because it's shiny.
and that's what luster is.
Whoa.
Shiny.
Luster is the shining of metal.
You know what? What is it with?
Because,
What's up with
and here's the important
the
part,
racism?
how is this coming to be,
Frustration.
and how is this being
Can
possible?
you tell me what?
So the shiny of the metal comes back from, you remember how Mr. Hall told you everything come back to connect together? Okay, Mr. Hall just wanted to make sure, because, I just, it's gonna come back. So the shiny metal, because many frequencies of light are absorbed and the electrons goes to the excited state. Oh, hold on a second, I almost forgot.
I know he's doing it again. We're always happy too.
So it goes to the excited state and will return to the ground state. And when it returns to the ground state, it releases what?
I mean, no.
Love.
I guess in this case.
Light's fine. You can say light's fine, but what's it going to give off? It gives off light, gives off photons. So goes to the ground state, releasing energy in the form of photons. It is okay, don't worry about it.
Charlotte, if somebody else in this class, not me though, were to forget what the excited state in an electron was, would you please explain it for them?
Yeah, oh yeah, absolutely.
It's not him though.
I mean, clearly, nobody would ever forget what the excited state
Yeah.
is. So,
And if they were, they'd be really, really stupid. Like
They'd be a real
astoundingly.
idiot. Forget
Especially
that.
after calling this class easy.
yeah.
Who would do that?
Luckily,
Who would do
nobody
that?
in this room.
I
right?
never said it was easy. I said compared to another class, it's, I would rather.
Yeah, like, it's a whole lot easier to talk about the Allied powers back in World War than it is to talk about
I
the
would
excited
rather-
state.
I would-
Stuff Mr. Hall.
I would rather be in chemistry for 4 periods a day than that class.
Well, me too, man. It's just because how great chemistry is, though. I mean, yeah.
You're so right.
Only class that comes close to chemistry is physics. Excited state is whenever electrons absorb energy and they go to a higher energy level. But then what happens is that's not the normal spot they're at, so they will return. But you can only have a certain amount of energy in those energy levels. So they have to release off energy. So the energy gets released off and we see photons.
So they get promoted and then they get scared and they have to let out.
So this is what's happening, like whenever you look at a metal, if you want to know why, like it's literally how mirrors are working for you. Now on the back of it, there's plating. What's happening is you are reflecting light off. It takes the light in, excited state, goes to ground state, reflects, and puts the photons back at you. Eli.
Well, other elements are also somewhat shiny, but what is it about metallic bonds that make them extra shiny?
It's the free electrons. So all these electrons that are free throughout. So it's like in Chicago, if you guys have ever seen it before, there's like a giant bean statue. And the bean statue is made of a metal. And as you walk up to it, it like reflects all sorts of light for you. And it's like what I said, like mirrors are perfect examples. Like why are you seeing the images that you're seeing through a mirror? Is it's literally the reflection of light into it that you get to see that comes back to you. So it's all about that for them, whatever energy they absorb, they're gonna release off. So whatever energy comes in, so that's why a mirror works. So if Eli goes over there and stands in front of that mirror, what color will he see from the hoodie is the actual true color of the hoodie? Because the light from the ceiling is hitting the hoodie, absorbs all frequencies of color, and whenever it goes back to the ground state, it releases off photons that I'm going to call it, ladies do not correct me please, it's not the point, I'm going to call it a light red.
That's clearly a salmon pink, Mr. Hall.
No, it
Like I said, girls don't correct me. So whenever he looks, he's going to see that true actual color. Talk trash about my class again.
I didn't know electrons could absorb energy. I remember
Or what?
explaining what an excited electron was. I don't know. I never
It's when they get
understood.
happy, right?
I think I missed the day you went over that, and then I came back and you tried to explain it to me, and I didn't understand. I was like, I don't need to know that. It'll be all right.
Well, that coffee was really, really good.
You're like that trend going around on TikTok right now with the dog who's sitting there like nodding with the music in the background, and it's like whenever my chemistry teacher is trying to explain a concept to me,
Well, see, sometimes
no,
like,
I'm going to fail the quiz.
like 4 days later, sometimes I'll be like, oh, that's how that works, and then I don't have to, make me waste any more time.
Yeah. Anyway,
Whoa.
so this is what luster is.
Yes, you
That's where the shiny reflection of the light's going to come from, where we're going to see it come from. Okay? So, second, did I answer your question? You got another question?
I got another question.
Okay, go ahead.
So the way the sea of electrons is set up,
Oh,
electrons release more energy than they would in an outer shell.
No, they release whatever amount of energy they absorb, they release.
It's that energy.
So in our shell, the electrons, they release some of it, but not all, but when they're outside, just in the sea of electrons, they release all of it.
So it's kind of, how to explain it?
I can take it from here.
You've got it under control.
The free ones are going to absorb the energy coming at them, no matter what. That's why you get the deflect of the mirror. Other ones that are actually bonded in atoms, that are connected with the atoms, that are in their energy levels, those electrons, they may absorb the energy, they may not absorb the energy. You'll know, it's like whenever we talked about the photoelectric effect. It wasn't about the intensity of the electromagnetic radiation that would kick the electrons out. What mattered was the frequency. So if you had the certain frequency that would do it, then that would go in there and would kick the electrons out. This is what's happening, per se. So it's like on that sheet of metal there, like that frequency of electromagnetic radiation would come in and it kicks them off. Is that helping?
Why is number 43's atomic mass in parentheses?
Technetium is very hard to collect through. They actually didn't know about the existence of technetium until, I want to say it was the 1940s. They had to build a very special machine just to collect it.
There's also Paulo.
Some of them are also, their half-life, like their atomic radii is so short
Is that
that their half-life is so short that they will we can't get an accurate number because it doesn't exist long enough for us
Is
to
that-
actually test.
is that an L or a K in 84?
And where?
84. I can't.
Polonium?
Yeah, oh, I thought it was Peconium.
Maybe you should wear those glasses, buddy.
Yeah, maybe you should. All right, so the second one we're gonna get into, these are more familiar to you, okay? You may not exactly understand the scientific term behind it, but you're familiar with it in some form or fashion, okay? Number two is, I'll go with this one because, yeah, let's do that. Number two, we're going to do malleability. Malleability is a very special property of metals that you all have used before in this room and you had no idea about it. Malleability is the ability to flatten a piece of metal into thin sheets. Perfect example of this. You ought to have used it before, unless you're a kid that you know. You cook. Your idea of cooking is putting Easy Mac in the microwave. But what you're looking at is aluminum foil. It's the perfect example of this. They take aluminum and they can just pound it out. Why is this taking place? Why is this possible? The reason this one's possible, this happens because the sea of electrons are not fixed in position. So they can freely move This literally gives the ability to bend metal, shape metal. So you remember how we talked about ionic bonds, and I asked you what would happen if I took a hammer and I hit that at one segment, and you talked about the negatives would line up, the positives would not line up, and it shears off? That wouldn't happen here, because what's going to happen? If I hit this with a hammer, so if I hit this segment here with a hammer, and I knock it down, what's going to happen? The sea of electrons are literally going to move. So they're going to move, atoms are going to move, and it just spreads out. Spreads out, spreads out, keeps spreading out. This is what happens whenever you're looking at people making aluminum foil, people making sheets of some metal. This is what's taking place, people. I thought there'd be more excitement with this, though.
It's pretty cool.
It's like everybody's just like,
I wanna see an example though.
It is very cool. But
You have
it's
metal?
like-
you want to see an example?
Yeah.
Okay.
I mean, but anybody can do that though. I wanna see the making of it. You gotta
Who wants to
bring,
see the man metal?
I don't have the equipment to make that. Are you nuts?
I think we can make it.
Okay, anyway.
Let's see.
Okay, you want to see the example? There you go. Okay, here's aluminum foil.
Yeah.
Fold it up, crease it up. Punch it. Why didn't it break?
Cause it's flat,
Because it's flat. Fine.
flattened it. The sea moved. the
See,
straw.
electrons gives the ability for it to move around.
Yeah.
You're not gonna break it. You can push on this all you want. I can always unfold it. How are you gonna get it to break apart?
Rip.
You actually can't, but here's the cool thing. Why is it? I can easily tear it.
The sea, the sea is built to move, not get torn and stuff.
Good, so thin.
Yeah, but you said the right thing. What's the sea of electrons able to do? It can move. That's why we don't get straight lines. If we want to get a straight line, we have to hold it on to a straight line and rip up, and then you still may have jagged edges. What's happened with it? The sea of electrons are able to shear off, able to move. The movement ability of the sea of electrons is what gives us all the special properties.
I'm sorry for the interruption, but
Oh,
at
no.
the bell, Mrs. Cook's second period class,
That is cool and
please
straw.
report to her classroom. Thank you.
Okay, so what you're gonna see is that is what gives everything special properties.
You ever made one of the aluminum balls that's like polished perfectly?
So I use aluminum foil for cooking and for a lab.
You should do the ball thing one day, it's fun.
So malleability and luster, those are the two properties we've hit. I still have two other properties I wanna hit. We'll probably hit those tomorrow, okay? So you all come, be excited, get a little bit more energy in you. Mr. Hall will be excited because he will be done with the gutters at the church. Praise God, right? Hallelujah. All right, so we've been hitting and talking about metallic bonds. Metallic bonds is the last and final bond that we're hitting. They are the creative ones that just look and say, you know what, we're just going to yeet these electrons out, and it gives all sorts of special different properties to them for this. So, the whole point of all the properties of the metals that we've talking about, all these properties of metals come from what?
Sea of electrons.
The sea of the electrons, okay? Sea of electrons give all the special properties. Why are the special properties there?
Sea of electrons.
What?
Because the electrons can what?
Move.
Move.
Like
Move freely.
Sea.
I can grab a hold of it and bend it. And bend.
That's kind of
Can I change the name to the Party of Electrons?
No. Okay,
I
so the
like
two
that.
properties we've talked about so far is Luster is the first one. And Luster is featured on Moana, if you've ever watched it. Moana with the crab, it's like oh so shiny. Yeah, no.
Best song of the whole movie.
I gotta be honest,
I actually sang it yesterday.
pretty back to
Straight best villain character. I won't die with that. But he was good. He was scary.
I like the regular.
was. But luster comes from that. So what gives luster its ability? How's luster possible?
Zone out for 3 seconds.
Absorbs the frequency of the light. What happens once it absorbs the frequency?
Electrons go to the next level and decide, nah, and it's
Don't say next level. Next level, sometimes it's not the next level. They go to the excited state, then what happens?
Then they go back.
They're partying, they're partied out, they're drained, they're like, man, you know, I'm going to, it's like Forrest Gump, like, you know, he went to the excited state and he just ran across the country forever, and he got to one side, he just turned around and ran to the other, and then one day he just stops running and he goes, oh, I'm gonna go to the ground state now.
They gotta
That
get
was
rid
it.
of all that energy, so it's releasing photons.
So then the energy goes, gets released off, and what do we get? We get the photons, and that's why we get to see the images that we can see. Okay, like mirrors are a perfect example of these. You're reflecting off photons of energy. It absorbs the photons of energy and reflects them right back at you. Those pesky electrons.
For malleability, is that just the ability to bend, right?
To flatten, shaping, and thin shit.
Malleable is such a good word. Hemoglobin's a good one.
Hemoglobin is a very good thing.
It's a good word.
So the ability to flatten out pieces of metal in the thin sheets, this is malleability. Why are metals malleable?
Because the received electrons are not fixed in one position, therefore they can be and move freely.
So, receive electrons freely move, so we can bend them, we can flatten them, we can shape them, we can do what we want to do. Gives them the ability to do this. Okay? Okay. Now, time for the third property. It's the hog gives the third property.
Is this a good one?
It's a great one.
Okay.
I got this, Mr.
So wait.
I got this. Let me just snap a quick photo.
Okay.
You are an anomaly.
There we go. Okay, you can,
Oh yeah, you weren't here yesterday.
yeah. You can get rid of all of that, Mr. Hall.
Number 3. Hey. Hey Mason,
Yeah.
stands up next time like you come into a class that you weren't here for the day before and you look out and the notes are left on the board. Instead of being on your phone and messaging people, maybe you should have tried copying the notes then.
I'm not gonna lie, I didn't look at the board a single time. I didn't notice.
All right, this one, number 3, is ductility. Ductility is hugely important to us. We could not have the life we have today if ductility did not exist. Ductility. Like,
I got you, I guess. I'm silly.
Number 2's on the back.
ductility is the ability
Ductility.
to pull a metal into pieces of wire. Think about copper wire, as an example.
I was walking down the hallway on my phone and I bumped into a hallway and my tooth hurts now. I said I bumped into a hallway.
You bumped into an entire hallway?
No, I bumped into a wall. And now my teeth hurt.
So the way that this is possible for pieces of metal to be pulled into a wire is based off of the sea of electrons. The sea of electrons
I'm starting to think that the seat of electrons are important.
move
Oh no. I can't reach balloons.
the sea of electrons move, allowing for the metal to shear off smoothly.
It's so real, dude.
Form clean cables, clean wires.
Is that like,
What does this
so
mean?
the ability to, or a metal to be formed into small thin pieces? Is that,
Isn't this just malleability?
what's the
Nope.
difference?
Yeah, what's the difference?
Malleability is flattening and bending, with that, but the flattening part. Ductility is we'll take the metal, and we'll pull it out into the wire.
So stretchability.
So, not so much as stretching, because we're not stretching it. We can't stretch it. You all probably have one of these with you.
Yeah, I know, yeah.
This could not exist if ductility didn't exist. Here's the reason as to why. The wire inside of here, it had to be pulled. We have machines that do this, but they'll take and pull it. Inside your house, you have electrical wire. Should have brought some with me to show it to you. But it's typically made from copper. Some we have are made from aluminum, but copper is better. Eli?
Where does rust come in? Does rust ruin a metal because the oxygen messes up the metallic bond?
Not the metallic bond, but what happens with it is rust is a reaction with the metal. So when you're looking at rust, it's actually something specific. Rust is specifically, it's iron 2 oxide. So what is it formed? Or it might be iron 3 oxide. Let me look it up. But what it is it's iron reacting with oxygen, and it's a totally new compound now. So now it's no longer a metal. It's reacted with something. It's like if you look at copper. Copper will not rust, but what it does is it actually turns green. The Statue of Liberty is not green, actually. The Statue of Liberty is copper.
I play Minecraft.
I think it's better green.
And then what happens, it's like the salt water even made it work. Yeah.
So it's not the ability for it to stretch.
It's not stretching,
It's not stretching.
we're pulling it.
But when you
Into a
pull
wire.
something, it stretch.
No.
Like, okay. So I know, like when they make wire, they put it in like that's like they have like a little machine here, and then they have like a machine here that kind of like just pulls it out. So that it's not stretch. It's the.
It's
a
not stretching it.
It's not stretching.
For
It's
lack
like
of better
it's
word,
pulling. It's pulling more copper from here and then making it thinner. It's just so hard to explain that. How, it's like I don't know.
It's
You just explained it.
I'm-
I would use the, I guess, what gets confusing is I would use the word malleable to describe that, but I guess elastic, I don't know.
See, I'm not crazy about the words because I always have to watch myself to get these mixed up. Because ductility, I think of ductwork, duct tape, stuff like that. And that are 10 pieces of metal. So I want to say ductility is the opposite, but it's not. Ductility is the wire. Okay? Now I'm gonna hit the one that you're gonna love.
You know, I'm trying to think of my own
Explosiveness.
definition for all I understand.
I love it when my metal explodes.
I do not. Especially since I became a homeowner.
Imagine you did it a couple times until it formed something that looked like a wall.
Number 4.
Everyone knows.
It's still weird.
It's very weird.
I set my
Like, I
things
know,
on
like,
fire
I
every
know how
day.
they're made. Yeah, but that doesn't make sense.
Electricity.
I made electricity, do you know that?
So you can explain to me how it works?
I will not do it because it's a secret, because I made it.
It's a trade secret, you got to have it.
I need that to make money.
It's because the electrons, Mr. Hall, they get to another energy level and they get excited, and then when you take the electricity out of them, they go back down
Have you
to
ever
the
seen
energy
an
level.
excited electron before?
Yeah, and they release
They're
their,
gonna stop.
they stop being excited and they release their electricity.
That's totally not how it works.
Well, it'd be pretty cool if it wasn't. I
Electricity
I prefer
is
science.
the flow of electrons.
Oh, wait, metal doesn't hold electricity. Does metal hold? Metal doesn't hold electricity, does
If
it?
you touch metal,
Capacitors do, but metal won't.
Well, trampoline
That's
does.
all electricity is
Static.
chemically.
Yeah, I know, it's passive.
All electricity is a flow of electrons.
How does lithium hold electricity?
Being acutely
Wait, it's not lithium, it's the acid, it's battery acid.
You're talking lithium batteries. I'll tell you what, Dale. You sign up for AP Chemistry and we'll talk about it. Because guess what?
I've always wanted to talk
It's
about
an
it.
AP Chemistry concept.
Can we make a battery? That'd be really
It
cool. to make
doesn't
one.
store the electricity or the electrons, it's just the flow.
It's just a
across.
flow.
can we make a poison and just so happen to pour it into Dale's drink?
Huh?
Huh? That
Hey,
wasn't
where's
me.
my drink kit?
That wasn't me. That wasn't
I'm
me.
nervous you would knock it off.
Basically,
That
I
wasn't.
touched it one time.
it's mature.
Oh, there's a camera.
Alright, so the flow of electrons. So, how is it that metals allow for electricity to flow through them?
Because they have free electrons and the other ones can flow through.
The sea of electrons.
It's weird, I feel like it shouldn't have happened.
I have a feeling that all the properties of
Even
metal
thinking
have
about
something to do with the
electrocutions,
sea of
like-
electrons.
Allows
That's top 10 worst ways to go out.
the electrons
What way?
to flow
Electrocuted, it's weird, bro. Have you ever been shocked?
in place
Like unplugging a cord and like getting
on a current.
It didn't hurt, it was just like.
It's terrifying. It doesn't hurt. It just doesn't really hurt. It just feels like.
Oh my gosh, I just thought of a great way to explain that. It's like candy. It's like when you stretch the candy. Oh my god.
I
It just
know
says
that.
not stretching.
Wait, it doesn't stretch though. See, that's so. Well, I guess
Dale, I know what you're talking about.
metal does stretch, Mr. Hall. What's the definition of stretch? It's like when you make like candy, right? You've seen like Dragon's Breath candy or Dragon's Beard candy where he's like holds it. It's like that, kind of. Because it's stretching, but it doesn't go back. You can force it back, I guess. Mr. Hall. I'm putting like candy. Y'all know what I mean when I reuse this.
For electricity?
No, I was still trying to think of my own way to
Searching up
write
right now.
free.
Definition of stretch.
Electricity, so this is how it works. So like right now, in this room, perfect example, I flip the light switch. Lights go off. Right now, from that breaker panel is wire that travels over to this light switch and connects in to it. Then, what happens is there's another part of the light switch, travels up to the light, and then there are wires that travel from each light to every other light. It all connects together. So then what happens is, the light switch is pretty much made like this. Right now I'm in the off position, so they're not touching. But then all of a sudden I flip the switch and I make contact to where now everything's together and electrons can flow through. So if I flip the light switch, it makes contact. Electrons can now flow. Since the electrons are able to now flow, then we have electricity going through to systems where they need to be, into the light, and this is what's happening. Now it's not with aluminum, but it's copper wiring. Electrons flow in, and as they flow in, it pushes all these guys. Now I don't have time for a physics lesson on, but I just done got time to teach you 3 chapters of physics to let you know how electricity is going to flow greatly for us and how electricity can be controlled with resistors and stuff like that. But needless to say, this is the simplistic idea behind it.
Did you ever electricity and physics?
Physics too.
What's the most
I can't do that.
conductive? Is it silver?
Copper, I'm pretty sure.
No,
Well, no,
silver's more
copper's
conductive.
The reason you use copper is cheap.
Yeah. Why does water, this is, you're gonna get mad at me for asking this because you're gonna get mad at me, but you might go over it later. Why does water conductive? Like, you know, why'd you two look at each other?
I don't
He doesn't know.
I know.
He doesn't
No,
know.
I know.
Oh.
He's clueless.
Funny.
Water doesn't conduct.
Oh wait, yeah, you told us, never mind. It's the stuff
No,
inside. the
I
water.
tell you, I
inside-
showed you.
What's the stuff inside the water? Like that is conductive.
Ions?
Not like the water molecule itself.
What kind of ions?
Cations and anions?
The water
Yeah.
ones.
The water ones.
You know, the ones in the water.
Water's funky. I forgot you talked about that.
Yeah, I want you to know I love you. It's the bottom of my heart. I feel like that we go a week in this class and Dale just sits there goofing off, typically talking with Tanner, and then eventually Tanner's not here one day, and all of a sudden Dale all just now cares.
I didn't.
And now he cares so much and he's trying and he keeps looking and he's like, oh, okay. Yeah. Nah, I'm lost.
No,
This ain't making sense.
I
Wait
remember
a
you
second.
talking about. No, it makes sense, Mr. All. It's just I remember you talking about it, and I didn't remember you talking about it, and I thought of it, and my brain went to a place where I was like, this seems like a reasonable question, which it is. It was a reasonable question. It's just that you've already went over it. Anyways, another question I had. So I was writing the note when you said this, but I'm pretty sure you said this. The electrons knock into each other and send each other away.
No.
Okay.
Electrons start flowing. It's like if you have a dam that's holding back water from a river, the river's flowing. If I break the dam, what's going to happen? Water's going to flow. Well, if there's water already after the dam sitting there, what happens when that water behind the dam starts flowing? It starts pushing the other water with it.
Okay, yeah. But I thought water didn't collect electricity.
It don't. I demonstrated that in the lab to you.
I'm not joking.
I should have came in earlier and set up that lab.
Hey, why do you do that laugh? You were taking the back of the sea off.
Yeah.
That makes it even more rich.
I was paying attention.
I'm used to that now. Any questions on metallic bonds?
We've learned to adapt.
I think metallic bond are pretty cool.
Is that the properties that we need to be concerned with? Are there more?
Are there more properties about? Yeah, but those are the 4 of the big ones.
If the properties don't change from the metal, it makes with another metal, right?
Oh, yeah. I almost forgot to teach about that. Thank you.
Whoa, that was like a cannon.
You saved my bacon. Okay. So, metal's very flimsy, right? Very flexible. See the electrons let it bend and stuff, right? Correct? What do they build skyscrapers out of?
Lots.
Steel.
Elastic rubber bands.
Metal.
Now wait a second.
You personally.
What's steel?
Carbon. And iron.
Show.
I,
Still on my
I
thunder
made it
now.
better. You were trying not to.
We got skyscrapers and we got buildings. In this building, they are beams of steel. Buildings have steel in them.
Oh, man.
Which is a metal. Since metal will freely bend due to sea of electrons, why use it? So the key answer to this lies within a hidden secret within metals. It's a hidden secret that we have. It goes by a very special name. This very special name, some of you have probably used them before. It's called an alloy. Alloy is a metal that has other substances mixed in with it. Now, I say substances because there's different types of alloys out there. Some alloys we have are meant to make things stronger. So if I wanted a stronger piece of metal, what I could do is I could make something called steel. We use steel in buildings. So it needs to be strong. We don't want it to be weak. So steel is an alloy that has iron and coal mixed with carbon. They typically use coal. You're right. So what happens with this is whenever the carbon gets in there, all the flexibility and everything behind the iron now changes. The carbon sticks in there and it makes it rigid and it won't bend. It's meant to withstand tons and tons of force. But then there's other types of alloys as well. Has anybody in here done any soldering?
No.
Have you not?
I did a little bit.
What do you use whenever you solder?
Solder. Heat gun.
It's good against
Thanks.
Solder is a metal alloy that melts quickly and hardens quickly. You have different things you can mix in with it. There's different grades to it. Whenever I go on next level jobs, we're always soldering cables together. We use this stuff to make cables to connect wires together so that signals can be transferred throughout. Well, how's that working? It's the flow of electrons. So alloys, can't believe I almost forgot about this, gives us more properties with metals than what we've ever desired. Because now we can mix things within it, change the metal to where it's going to make the metal be able to do different things. And it depends what you mix within the metals. You just gotta play around with it. Okay?
That's pretty cool.
Pretty nice.
I think this is the most interesting lesson so far, in my opinion. To me, this is the most interesting one.
Metal is cool. Metal is cool.
It's just so cool that like you can, like, I don't know, the reason they move, you know, the reason they have,
Hey,
you
Dale.
know, they flow electricity.
it. What's the last one?
Let me finish nomenclature and getting chemical reactions. It'll be your favorite.
I don't know if strong metal.
That actually sounds pretty cool. Metal.
I set a gummy bear on fire.
That's sick.
That's pretty cool.
Like, I mean, I'm talking, like, I torched the daylights out of it.
And you didn't let me eat it?
What did the gummy bear do to you?
Wait, if a gummy bear is torched, is it still edible? You safe to eat?
No, like, it's gone.
Um,
I vaporize it.
It's
Oh.
still safe to eat if you
You
eat it.
vaporize a gummy
I
bear?
vaporize it.
oh,
I'd say
Guys, let's
it's a
go.
lot different than what I
I'd say
thought you were
it's
gonna torch it. Uh-oh.
A guy I stood taught under whenever his kids went to take the AP chemistry exam. He made them all come up to his room before they did it. And he had the demonstration set up. And he did it. He said, and now make a sacrifice to God, that He will accept this sacrifice and help you pass your AP chemistry exam. And whenever it goes in, there's a lot of vapor that comes off. Like you'll watch, I'll turn the lights and everything off, and then I'll turn it back on. There'll be a cloud in the room. And he'd be like, breathe it in.
Can we, wait, what was the really strong smelling stuff that we put on the hot plate?
Lauric acid.
We need to burn that as an aroma pleasing to the Lord. I'm
No.
reading Leviticus.
I
No,
feel like I've only been here for like.
no, I'm gonna tell you right now,
This is the last-
there ain't no lauric acid in Leviticus. I'm gonna stop here on Monday. I'm gonna start on something called later. Valence shell electron pair repulsion. It has an abbreviation called VESPR, but we call it valence shell electron pair repulsion. I don't want to get started into it because it's going to be really pointless for me to just briefly get into it and then have to refresh your memories on Monday. So enjoy it. I'll give you 4 minutes free.
Hi.